Hello students, welcome to my channel Positron. Since last few days I'm making videos over the capacitor and many videos already have, 6-7 videos I have posted, right? So today's topic is a capacitor, some tricky problems like the problem based on the problems of tube capacitors. Like so many problems I will discuss with you all, right? Some symmetry problems like the folding symmetry, mirror symmetry, path symmetry, like so on. So dear students, the first question that I have from many books I have considered these questions I have selected through many books. First one is this is C, right? This is 2C, this is 2C, this is C, and this is C, and this is C, like this, and again this is C, and this is the C, right? Let these points are A and B, this is L, M, N. Dear student, these are C, C, this is 2C, 2C, this is C, C, this is C, C. We have to do, we have to find out the equivalent capacitance between A and B. Dear students, here two kind of symmetry you can observe. If you take perpendicular bisector or this one, perpendicular doesn't mean that exactly perpendicular. Means in mid of the circuit, if you see, left and right is exactly same, right? So it is a mirror symmetry. In the case of mirror symmetry, what we do, these points L, M, N, the points of the junction are the common potential points, so no current is going to flow through this, right? So easily you can solve. Now this is CC is in series, so have the equivalent capacitance. You know, if there is two capacitors of equal capacitance and they are in series, then their equivalent will be half, or you can solve like this, C into C upon C plus C, and that becomes C square over 2C, or you might write C by 2. Similar way, CC is again, these two I have removed because it's not going to work, or you can remove in this way, right? Now this CC has the equivalent capacitance C by 2, and now this is 2C, 2C is again in series and their equivalent will be C. Now dear students, if you redraw this circuit, then it is C by 2, this is C, and this is C by 2, and this is point A, this is your point B, this is C, C by 2, and equivalent will be, all these connections are in parallel, so equivalent will be C by 2 plus C by 2 plus C, or it will be C, C, that is 2C. In this way you can solve it very easily. Dear students, here, you know, in series combination, charge remains same, potential is divided, whereas in parallel combination, charge is divided and potential remains same, right? So, what we have done, we have taken the common potential points because of mirror symmetry, then the capacitor between these common potentials we removed, because if the potential is common, no charge is going to flow. So, this CC will be in series, right? The charge will travel like this, and this 2C will again be in series, and this CC will be in series, and further these three will be parallel to each other, and you can find this. The same question you can solve like this. Now look here. The same question, again I am redrawing this circuit and trying to solve with another method. DH3 it was CC. If you look below AB and above AB, right? Circuit is exactly same. This is C, this is C, C, this is 2C, 2C, C, 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 like this. Now, if the circuit is exactly same, you can apply, if above AB and below AB the circuit is same, it means it is a folding symmetry. If you apply the folding symmetry, Then dear student, this CC will be parallel, so it becomes 2C. In folding symmetry means if you fold it, then C and C will be parallel, this CC will be parallel, and again it becomes 2C in this way. Now look here, this 2C remains unchanged, nothing you are going to do over this. This is 2C, this is 2C, and now this CC is again parallel, and so it is a 2C, right? If you fold it, this C and this C will be parallel, this C and this C will be parallel, this C and this C will be parallel, whereas these 2C will remain invariant because no capacitor is going to lie on these. So this was the point A and this is the point B. Now dear student, look here. This is a Wheatstone bridge simply, and so this is let P, this is M. P and M will point a common potential, and in this case it's not going to work. Then what happens? This 2C will be in series, this 2C will be in series, and the equivalent of this 2C and 2C will be C, whereas this 2C has equivalent C, and now these two are in parallel, so C equivalent is going to be C plus C, that is 2C. Whatever method you apply, no matters, right? If you redraw circuit, actually what it means of equivalent capacitance, how do I used to say that this 2C has equivalent capacitance? Equivalent means whatever these two capacitors doing all together, simultaneously, the same job will be done by a single capacitor if this combination is removed by single capacitor having capacitance C. Means these two capacitors are removed by single capacitor C, and whatever job these two capacitors were doing, the same job equivalent capacitor was doing. So either you apply the mirror symmetry or folding symmetry. From both the methods you can solve this problem. Next, let's move ahead. Next problem is, dear student, next problem is this is, look, this is 2C, this is 2C, this is 4C, right? And it is again 2C. This is terminal A, this is terminal B. These are 2C, it is CC, and this is 2C, right? Dear students, the problem is that this is 4C, 2C, 2C, C, 2C, 2C, like this. Now, dear student, it is again, it's a very good symmetry. If you take a perpendicular bisector at the mid, then whatever is there, the same circuit is here. Or you can say, what we have to do, we have to find out the equivalent capacitance of the circuit between the points A and B, between the terminals A and B. What I have done, let charge Q1 goes to this side and Q2 goes to this side. Now this Q2 is divided into this. It's a Q2 dash goes this side and Q2 minus Q2 dash goes in this branch. Now dear student, this Q1 charge is clearly whatever charge is received by this capacitor, the same charge will flow through this, right? Because of symmetry, whatever charge is received by the C capacitor, the same charge received by this one, and whatever charge is received by this 2C capacitor, the same charge will be received by this 2C capacitor. Then you can say this junction M is irrelevant, it's not going to work, so you can break the junction in this way. And because even after breaking the junction, there is no change in the symmetry. If you break the junction, symmetry should not be disturbed in the circuit, right? So what step we have taken. We have removed the junction, but the symmetry remains intact, invariant. There is no change in the symmetry. Now, dear student, look here. It's a very simple problem. This 2C and 2C, again, they are in series. Their equivalent will be C, and this C will be parallel to this, so it becomes 5C. Now, look here. This 2C, 2C are in series, their equivalent will be C, and this C will be parallel to it, so it becomes 5C. Now, dear student, look here, this 2C, 5C, 2C are in series. 2C, 2C has the equivalent C, and C and 5C, you can write 1 upon C1 or C1 directly. C1 is equal, if the two capacitors C1 and C2 are in series, then their equivalent will be C1, C2 upon C1 plus C2. Again, try to listen. Try to understand this. This is 2C. These 2C are in series. Their equivalent will be 2C into 2C, or 2C plus 2C means 4C. CC will cancel. This is 2 cancel. That is C. Means here the equivalent is C, and this is parallel to it, so it is a 5C. Now, dear student, this 2C, 5C and 2C are in series, or you can make like this. This is 2C, this is 5C, this is 2C, and this CC is again in series. Their equivalent will be C by 2, right? It is point A, it is point B, this is 2C, this is 5C. Now, 2C has the equivalent C, and C and 5C will be in series, so it is C into 5C, or C plus 5C, that is 6C, and CC will be cancelled, so it is a 5 by 6C. C1 becomes equivalent of this branch. What we have got, that is 5 by 6C, and this is parallel to C by 2, so the C equivalent finally will be, that is C by 2 plus 5C over 6. Now, 6 would be the LCM. 2 3 is 3C plus 5C, that is 8C by 6, or you can say 2 4 is 4 3, 4C by 3 is the equivalent. In this way, we have find out the equivalent using the mirror symmetry, right? By the charge travel on the path, we have derived this, right? So, I am moving ahead to the next question. Third problem is, yes, when this problem has been asked many times in JEE. These are, you can say, such a problems are generally asked in JEE, and especially in NEET. This is a triangle, each having capacitor C, right? This is the triangle, each having capacitor C. Let this point is A, this is B, this is C. Another triangle having each capacitor C like this. All these having again, and these are the junction having 2C. This is again having 2C. And this is again having 2C, right? All these junction capacitors are 2C. Now, we have to find out, let this A, B, C. Write it E, because C we have denoted for capacitor, and you can write it M, L, N. Find equivalent capacitance between number 1 A and E, number 2 between B and M. This is the problem. Dear students, what we have to do, the question is very simple, that in the figure a circuit is shown, and what we have to do, we have to find out the first, these are the two triangles, each edge has the capacitor C, and these triangles, the vertices of these triangles are connected by 2C capacitor. In first case, we have to find out the equivalent capacitors between A and E, and in the second case, we have to find out the equivalent capacitance between B and M. Now first, we have to find out the between A and E. If you draw a perpendicular bisector, now dear student, look here. The whatever is there left in, the same is their right side, right? Means circuit, the two sides, left and right hand, are mirror image to each other. So you can apply the mirror symmetry. B and M are the common points lying on the perpendicular bisector, or B and M are the junctions lying on the perpendicular bisector. So B and M are the point of common potential. If they are the point of common potential, then you can remove this. 2C capacitor is not going to work, because if the potential is same, the potential difference would be 0. No charge will flow through that, and so you can remove that capacitor. Now look here, it becomes very easy. If you want to find out between A and D, look, this C and C are in series, their equivalent will be C by 2. Because whatever charge will go, the same charge will flow through this. So C and C are in series. Now look here, this CC again in series, so it is C by 2 again, and this C by 2 is parallel to this C. So C by 2 and C, if you add, because in parallel directly you add, so equivalent of this circuit will be 3C by 2. C plus C by 2, that is 3C by 2. Now dear student, 2C, 2C, again they are in series, they are equivalent again, this, all the three are in series. This 2C, 3C by 2 and 2C are in series. So 2C, 2C has the equivalent C, and now C and 3C by 2 are in series. So their equivalent will be C into 3C by 2 over C plus 3C by 2. So it becomes C into 3C by 2 over 2C to 5C by 2. Now dear student, 2 cancel, C cancel, this is 3 by 5C. Again try to understand please. What I have said, that if you are going to find out the equivalent capacitance between A and E, then I have taken the perpendicular bisector of the circuit. Left hand side and right hand side were exactly equal to each other, were mirror images to each other. So B and D, this B and this point was M. B and M were on common potential points. So whatever the capacitor was between these 2 points, I have removed. If you remove, the circuit becomes so simple. Now this CC are in series, their equivalent will be C by 2. Now this CC again are in series, this is C by 2, it is parallel to this C. So C by 2 and C, the equivalent of this becomes 3C by 2. Now dear student, 2C, 3C by 2 and 2C are in series. So 2C has the equivalent again C, and C and 3C by 2 again are in series. This 2C, 3C by 2 and 2C are in series. So for the convenience, 2C are in series, their equivalent is C, and C and 3C by 2. Then I solved and got this equivalent. And now this is C. So this C by 2, this 3C, this 3 by 5C and C are in parallel. So equivalent will be, dear student, look, this branch has the capacitance C, this has the equivalent 3 by 5C, and this one has the equivalent C by 2. Now it becomes 10 LCM, this is 10C plus 6C plus 5C. So it becomes 10, 6, 16, 5, 11, 16, 5, 21C by 10. The equivalent will look here, 10, 16, 5, 21. 21C by 2, 10 would be the equivalent between terminal A and B. Now dear student, the second part is that we have to find out the equivalent of the circuit between point B and F. Now how? Let's move further. Again I'm redrawing this circuit. Now look here. It was C. This is C. This is C. Again a triangle is C. This is C. This is C. Now dear student, these are the junction capacitors 2C. C, 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 this is 2C, C, 2C, this is 2C, this is C, C, and it was perhaps A, this is B, this is C, and this is M, L, N. Now, what we have to do, we have to find out the equivalent capacitance between terminal. First, we find out the equivalent capacitance between A and C when the terminal was A and C, between which we have to find out the capacitance. Then we have taken the perpendicular bisector of this one. Now, what we have to do? We have to find out the between B and M. Now, look here. What we have to do? We have to find out the equivalent capacitance between terminals B and M. If you turn it, right, then again, it is a same symmetry you can apply. It's a symmetric image you will get. Left and right hand are exact symmetric to each other. Or you can apply a concept. If a charge begins from M, it comes in this way. Now it passes through C. And now between these two again C. And the same charge will pass through this. And so no charge will flow through this. Or you can say, for point, if you are going to find out the equivalent capacitance between B and M, this time Ln and AC are common potential points. So this capacitor is not going to work. Again, dear student, try to understand that if you are find out the equivalent capacitance of given circuit between the two terminals B and M, if the charge flows begins from M in this way, comes here. Now look here, this charge passes in the same manner. Here passes through C, again passes through C, comes here. Between these two there is a capacitor C. It means it is a common potential point. And again it comes, passes through 2C. Thus this charge also passes through 2C. Means again this A and C are the common potential points, you can say. Or by the symmetry you can say that these Ln and AC are the common potential points because of mirror symmetry. So this is not going to work. If it is not going to work, you can remove it easily. Now what becomes? Now look here, this C2CC are in series. Look here, this C2CC are in series. CC has the equivalent capacitance C by 2, and this C by 2 and 2C equivalent will be, again this CC has equivalent C by 2, and with this 2C again it is in series. So you can solve it C by 2 into 2C or C by 2 plus 2C. So it will be, you can say C by 2 into 2C over, this is 2 2 ja 4 1 5 C by 2. 2 will be cancelled, C will be cancelled, this is 2C by 5. Now this is again 2C by 5. And so if you redraw the circuit, this was the point B, this was the point M, between this was point B, and between B and M there is a capacitor of 2C, and this circuit has a 2C by 5, and this circuit has equivalent 2C by 5. Now between B and M the equivalent capacitance will be, C equivalent will be 2C upon 5 plus 2C plus this. So simply you have to add, 2C plus 2C by 5. Now look here, 5 would be the LCM. This is 2C plus 10C plus 2C, 4C, 14C by 5. This time equivalent will be 14C by 5. Okay? Dear student, again I have applied the mirror symmetry. Right? we found the common potential point. Between the common potential point, whatever the capacitor was, we removed it, and finally we solved and got the result out. Right? Let's move further. Next is a cube problem. In the case of cube, many kind of problems might be asked, like this problem I am considering. Let it is A, B, C, D, it is E, F, G, H. Dear student, this is, we have to find each capacitor across each edge of the cube is, see, there are the 12 capacitors. We have to find out between the equivalent capacitance. This is first part left. Equivalent capacitance between first A and F, second between A and C, third between A and D, like this, right? This is the problem that we have to discuss. So first, let's try between A and F. A and F are the opposite points of the diagonal. Between the opposite points of the diagonal, we have to find out the equivalent of this cube circuit, right? You can apply many methods. By the common potential you can solve. First I am going to solve it. Let it is connected with a V-volt battery, right? And for the convenience, for the simplicity, let 6Q charge is issued by the battery. Dear student, if 6Q charge comes, because it would be easy to distribute, that is why I have supposed 6Q. This will receive 2Q, this will receive 2Q, this will receive 2Q. In the similar way, at the output, here the three junctions are meeting. So from here it is 2Q, from here it is 2Q, from here it is 2Q. No doubt, here will be Q, here it will be Q, and again here it will be Q, here it will be Q, QQ will be 2Q, and look here, this, it is receiving Q, so here it is Q and here it is Q. In this way, so this becomes 2Q, QQ becomes, this QQ becomes 2Q, and now this QQ becomes 2Q. These three junctions are meeting, so it is 2Q, 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 means 6Q charge is received. Dear student, whatever charge is released from the battery, the same charge is received by the battery. If it is not so, then your circuit is not going to be right. For the exact circuit, for the right circuit, you should follow that whatever charge will be released from the battery, the same amount of charge would be received by the battery. On the same concept I have applied, and I have redistributed the charge to the circuit. Now what I am going to do, I am going to apply the KVL, Kirchhoff voltage law. Any loop, closed loop you can consider. For simplicity, let's consider this loop, right? This outer loop, like this. So, considering loop, applying KVL over loop, over mesh or loop, what is A, H, G, F, A, H, G, F, V, A. This is, you know, KVL is applicable only to the closed loop or mesh. Now look here. If you move in the direction of charge, then it is it has a charge 2Q and capacitance is C. Q is equal to, you know, Q is equal to CV. So V is equal to Q upon C. So DA student, here the potential will be, 2Q upon C, right? Here the potential will be 2Q upon C, and again you are moving in the direction of charge. Here the potential will be Q upon C, and here again it is 2Q upon C, and you come to the negative plate of the battery, so minus V is equal to 0. Actually it is, you know, summation V is equal to 0 over closed loop. You might write it like this, summation V is equal to 0. Now dear student, if you add this, this is 5Q by C is equal to V, but the charge is 6Q, right? The battery has issued the charge 6Q. So you can write like this. Now look here, C is equal to Q upon V, you might write. So Q upon V will be C upon 5. But because 6Q charge has been issued by the battery, so I have multiplied by 6 both the sides. That is. Now look here, 6Q, the total charge issued upon the total voltage of the circuit is equal, the total charge divided by total potential, that is equal to equivalent capacitance C equivalent, and that is equal to 6C upon 5. This is the easiest method to solve this one, right? We apply the KVL and taken just the outer loop and we got the result. This works to be 6C upon 5. Dear student, the same problem can be solved. The second method you can say, this is by common potential. Just look at the common potential points. Now look here. What we have to do, it is E, F, G, H. We have to find out the equivalent capacitance between A and F, right? First, I have written the terminal, the name of point of terminal between which we have to find out the equivalent capacitance. So what we have to find out between A and F. So I have written here A and here F. Now look here. Whatever is for the A, point B, D and H are at common potential. Why? Because at B, either be D or be the H, the charge has to pass through one capacitor only, right? So B, D and H are the common potential points. Again I am repeating my verse, because up to B, D and H, charge has to pass through once time the capacitor. So B, D and H are having the same potential, B, D and H. Now look here, with respect to F, you can say the similar points are what? The similar points are, with respect to F, the similar point is C, similar point is E and similar point is G. CEG is similar point with respect to F. Why? Because from C to F there is a one capacitor through which charge has to pass. From E to F there is a one capacitor through which charge has to pass up to reaching up to F, and from G to F there is one capacitor through which charge has to pass. Now dear student, let's make between A, this is A. Now move from A to B, there is a capacitor C. From A to D, there is a capacitor, another capacitor C. From A to H, there is a capacitor C. Now this is a BDH and this is CEG. Now look here. From B to C, there is a one capacitor. Then from B to E, there is a capacitor. B to E, there is one more capacitor. Then B to C, B to E. And then next point is a D point is where? This. From D to C, there is a capacitor. Then from D to G, there is a capacitor. Now next is a H. Look at H is where? H. Now look here. From H to G and H to E, there is a capacitor. So here are the 6 capacitors. Now dear student, from C, E and G, from C to, look here. Now we have to find out between F. C to, let it is a point F. From C to F, there is a capacitor. From E to F, there is a capacitor. And then G to F, there is a capacitor. Now look here. Each one is a C. So it equivalent of C, this is 3C. Now this is 6C. 6 capacitors are parallel and this is 3C. Now dear student, look here, 6, 3, 9, 3, 12, this cube is consisting 12 capacitors. Now all these are in series. So what would be the equivalent? This is 1 upon C equivalent equal to 1 upon 3C plus 1 upon 6C plus 1 upon 3C. LCM would be 6C. 3, 2 jar, this is 2 plus 1 plus 2. This is 2, 2, 4, 1, 5. Our C equivalent is going to be 6 by 5C. This is, right? C equivalent is going to be 6 by 5C. Now dear student, let's move further. The second case is, the same cube I am considering, right? Again, I am giving name A, B, C, D, E, F, G, H. Dear student, last time we have taken the point across the diagonal of the cube. This time we are going to take the surface diagonal, the point across the surface diagonal. Let the points are A and C, right? The points are A and C. Actually, let charge Q is passing through this one. Then charge Q, the same charge will pass through this one terminal also. Why? Because this charge has to pass through this, and this charge has to pass through this. And let charge Q1 is passing through this. Dear student, you can apply a very nice concept. If Q charge comes, then this branch, the Q charge is released in this branch. This branch receives Q charge and this branch receives Q charge. In the same way, with respect to C, you will say that this branch receives Q charge, this branch receives Q charge, and this one receives Q1 charge. Whatever the way charge enters in the circuit, in the same way I have applied that charge leaves the circuit. Here, this branch Q charge enters, in this branch Q charge enters, in this branch Q1 charge enters, and again you can say here Q charge enters, here Q charge enters, here Q1 charge enters, right? These two are similar, but this is a different because from here charge will go with this and then come like this. That is why in this branch we have considered different charge. Now dear student, look here. If this circuit is tube, the distribution of charge tube, then it is not going to work because it is not receiving any charge. And in similar way you can say whatever the charge is coming is just leaving the circuit. So this circuit, this capacitor again is not going to work. Now it becomes very simple. Look here, these two are in series CC, their equivalent will be C by 2. This CC is in series, their equivalent will be C by 2. This and this are parallel, so their equivalent will be C. It is point A and C. Now between A and C we have to find out, sorry to say, if something else I have written in the question. Actually, through the surface diagonal we have to find. Now dear student, look here. This is CC, again it is C by 2, right? This CC series, so their equivalent is C by 2. Now this C by 2, this C by 2 is in parallel, so their equivalent will be C. Again, this is C and this is C. Now between A and C we have to find out the equivalent. C, C, C. All four are the C, C, C. Again you can see, look here, between A and C, this is C, C, C by 2. This C, C are in series, so their equivalent is C by 2. These two are finally in parallel, so C by 2 and C by 2 has equivalent C. Now this is C, this one, and this again it is C by 2, it is C by 2. They are in parallel, their equivalent will be C, and this is C. Now between the terminal A and C we have to find out the equivalent. Dear students, it's very simple. These three are in series, their equivalent will be C by 3. And now this C by 3 and C are in parallel, so how will you find out? C equivalent will be C into C by 3 over C plus C by 3. So it becomes C into C by 3 over 3, 1, 4 C by 3. This 3 would be cancelled, C will cancel, and the answer would be the C by 4. Am I right? C by 3, C into C by 3 over C plus C by 3, that is 4C by 3, 3 will cancel, C will cancel, this is C by 4, right? Right? So it is for the surface diagonal we have find out the body, between the body diagonal points, the capacitance works out to be, capacitance of Q works out to be 6C by 5. Between the surface diagonal points, it works out to be C by 4. Let's take third one. Between the points lying on the edge. Third one is, if the points are lying on the edge, right, then what would be the look here. First make Q, then show the capacitors, like this. Let these are the points between which we have to find A, B, C, D, E, F, G, H. Dear student, this problem is a bit typical, right? You can say this problem is a bit typical than other two problems. So better is many methods, any method, nodal analysis you can apply, many methods. In my last video I have explained and tried to make gossip for the nodal equation. This time I'm going to apply something different. Let A and B terminals are connected with 2-volt battery. Dear student, what I have considered, let A and B terminals are connected with 2-volt battery. If it is V, then this point is a minus V. Now, look, with respect to point A, if it has a potential V, let it has a potential X, then this also has potential X. In similar way, this is a minus V. With respect to minus V, it has the potential minus X, and this has the potential minus X. Now, with respect to X, if H has the potential Y, then G has the potential minus Y. Each edge has a capacitor that I have not shown for not making too much rough. Dear students, try to understand again the distribution of potential at different points. What I have done, I have connected with 2-volt battery between point A and B. I have applied a 2-volt battery. Now look here, if it is V, then it is minus V. V minus minus V becomes 2V, right? So it is a 2V-volt battery I have applied between A and B, and A and B are the points between which we have to find out the equivalent capacitance. Dear students, with respect to V, point D has a potential X, and same is with respect to A, D and E are common potential points. So if it is its potential is X, then it also has the potential X. Now with respect to B, C and F are common potential point. So if with respect to V, D has a potential X, then with respect to minus V, it has a potential X, and this also has a potential minus X, similar to E. And let with respect to X, it has potential Y, then with respect to minus X, it has potential minus Y. Now dear students, two unknowns we have got, right? X and Y. The two unknowns we have got. So we have to, this is a nodal analysis method. In the nodal analysis method is a most accurate, shortest and fastest method. But the important is that how do you distribute the voltage across the point on the points. So now voltage distribution is over. So we are going to apply the nodal equation for X and Y separately. Writing down nodal equation for X and Y. Let's move for the X. We may write, now look here, X minus V. Dear student, what is nodal equation means? Here is a capacitor, here is a capacitor. These, the charge summation Q is equal to 0. The total charge, these three capacitors are independent from the exterior world, right? From the external world. So you can write the charge on this capacitor Q is equal to C into V. This is C into potential will be always, if you are writing the nodal equation either for X or for Y, then X and Y undoubtedly you have to assume they are at higher potential. So X is higher potential than V. So potential difference would be X minus V. Plus for this it is X minus Y into C. And for for this capacitor, it is X minus minus X, that is 2XC equals to 0. Now dear students, C will cancel. So it is X 2X, that is 4X minus Y minus V equal to 0, or 4X minus Y is equal to V, equation 1. Now write down this, let's write down the equation for Y. This is Y. These three capacitors it is connected. So summation Q over these three capacitors would be 0. So for this it would be Y minus X into C. For this it is y minus y means 2y into c, and for this it is this is y minus x into c equals to 0. This c will be cancelled. Dear student, this is y, this is 4y minus x, that is minus 2x equals to 0, or 4y is equal to 2x. Now, y is equal to 2x by 4, 2 2s, that is x by 2. The value of y is that is x by 2. You have got the value of y, that is x by 2. Now, dear students, what we have to do next? We have written down the nodal equation for x and y, and finally got the values of x and y. Dear students, what we have to do? Let the charge here is q1, here is q2, here is q3. Then equivalent capacitance is what? Total charge q1 plus q2 plus q3 divided by total potential difference 2V. Look here, it is not V. Here you have applied 2V for your convenience, because the distribution will be V minus V, like this. For that reason we have applied 2V. Okay. So now look here, and that is why we are dividing by 2 volt. Now dear student, look here. C equivalent Q1, this Q is equal to C into V. It is V, and X is what? Look here, sorry. Y is equal to X by 2. If you replace here Y is equal to X by 2, then it is 4X minus X by 2, that is equal to V. 4 2 is 8, 1 7 by 2X equal to V, or X equal to 2V by 7. So, dear student, Q1 is equal to, look here, X is 2V by 7, right? So, C into V, this is C. Q is equal to C into V. Q is equal to C into V. You have to find out the charges in these 3 branches. And this is the total charge if you add. That is the charge enters from the battery, because once from the battery, charge comes here, it is divided into this, into this, into this. Then it is further divided, it does not matter. But initially, that whole charge is distributed in these 3 branches. That is why if you are capable to find out the charge across this, this and this is the total charge issued by the battery. So dear student, Q1 is equal to C into V is a what? V minus 2V by 7. So it is a 5V by 7. Again come Q2 is what? Q2 is that one. V minus V means 2V into C, plus again this is same, it is X means 2V by 7, V minus 2V by 7 means you will get the same value, C into 5V by 7 divided by 2V. Dear student, easily you can solve this now, right now. How? Look here, I am removing this one, and the C equivalent will be, look here, 5 CV by V, we cancel it from everywhere. It is 5C by 7, 5C by 7, so it is 10C by 7 plus 2C divided by 2. Dear student, it becomes 7 to the 14, 10, 24C, right? By 7 into 2 to 12, this is 12C by 7 is the equivalent capacitance of the circuit when the points are considered across the edge. If the 2 points are the 2 terminals which are across any edge, then the equivalent capacitance of the cube will be 12C by 7. With these words, very good night to you all. Dear students, I have tried my best to let you understand whatever topic was going on. If you think that my videos are helpful to your studies and you think that with the help of me, you can solve the problem easily, then please and please, it's a very humble request to you all that please like, share, subscribe my videos and must put the bell icon so that you might be notified about my next video. Thank you.